This first one. Tell me, Nick, what do you do?
You're going to do 120 minus 180. That number you're going to divide by 2 to get y, because they're going to be equal.
Good job. Okay, so these are congruent, which means it's isosceles, which means your base angles, which are those two, are congruent. So this is y. So you're going to say 2y plus 120 equals 180. Take away the 120. And then divide by 2. Okay, so y is 30. I believe you, but I want to give everyone a term.
It's one question.
Right. It's okay. You did a good job. Let's see if anybody else knows it first. And then if they don't, then you may have it. Anybody want to find x for me? I didn't use 90. Okay, so look at this one. If these...
61. I know, I'm looking at the wrong one.
What are you looking at?
I was looking at it.
Are we doing x?
Oh. So if these are congruent, then your base angles are congruent, meaning this is 45, right? So now you have 45, 45, and x equals 180. So take away the 90, and x will be 90. Ava.
So on this x, because I feel like with especially x, it's kind of, you could do that mentally. Do you want us to write out that equation, or can we just write it?
On a problem that is like this, where you could just like subtract, divide, call it good, that's okay. You just won't get any credit if you do it wrong, right? Whereas if you write it out for me, but then you do the math wrong, I will give you some credit for that. So I recommend you write the steps. But yeah. All right, number 2. Take a look carefully at which sides are congruent and therefore which angles are congruent. So if these are the two sides that are congruent, then which two angles are congruent? Nick, you are so excited about that. Good. These two would be your two congruent ones, right? So x is going to be 63. And then how do you find y?
You add them together and subtract 180.
Right. Y plus 63 plus 63 will equal 180. So take away the 126. And y is going to be 54 degrees. Okay. Number 3. I want you to be able to recognize... Girls, you with me back there? Stay with me. I want you to be able to recognize that when you have an isosceles with these two angles congruent, that something else is going on here. What's the something else that's going on? What do we know in this picture?
What half is it?
Okay. We know we have a right angle. We know we have a perpendicular bisector, right? Whenever an isosceles triangle has the vertex angle cut in half, then this is going to be 90, and these will be congruent. Okay, it is a perpendicular bisector. So when they ask you for the measure of angle ADB, what is it? 90, right? ADB is this angle. ADB is 90 degrees. So then how do you find the measure of angle A?
The other side is 32, and then you get 64.
Okay, so you could do that. We don't have to do that.
32 plus x.
Yeah, I would just take this smaller triangle right now. So x plus 32 plus 90 should equal 180. So take away 122, and you get A is 58 degrees. Okay, you could do what Luke said. If you do that, then this top angle is 64. So 180 minus 64, and then cut that in half if you want to do it that way.
Let's go.
Number 4, does it make more sense to find M or N first? M. Okay, so look at M. If you look at this triangle, okay, notice this triangle is marked isosceles, which means base angles are congruent. So because that other angle is 45, then M is going to be 45 also.
How do we know the other angle is 45?
They gave it to us.
Oh. My bad.
No worries. Okay, now, if you look at the other, oops, sorry, I didn't mean to cross that out. If you look at the other triangle, this triangle right here, okay, the markings in that triangle are this. This is what we know. What do you do, Nick?
Well, they're all equal, so you're just gonna do 60 and 60
Why are they all equal?
because of the markings that they have. That shows that they're
But
congruent.
this one has a double mark on the bottom.
I mean, it's just like simple math. You know, it's 60 though.
We do know it's 60. It is 60. This is actually equilateral, even though that marking on the bottom doesn't make it look like it is. That marking's more for the other triangle, right? But because these are congruent, that makes these base angles congruent. So if I just call this x and x right now, then 2x plus 60 has to equal 180. So take away the 60, so 2x equals 120, and then divide by 2. So x is 60, so this is equilateral. So here's what you have to see. This angle is 60 degrees. What is n? What is this little sliver then?
You have to take away 45.
Yeah, you got to subtract the 45-degree angle. So 60 minus 45 makes n 15 degrees. Okay. Any questions 1 through 4? Okay, that's one page of your test, is just problems like that. Find the missing angle measures. Okay? Page 2 of your test is this one. There are 9 different sets of triangles there. I want to know, are they congruent, and if so, by what? So here's your options. We learned SSS, SAS, ASA, AAS, which if you wrote it as SAA, same thing, and HL. Okay? If none of those work, then you write NEI. So I want you to work with someone around you, or 2 people around you, or 3 people around you in a group of some sort to figure out what those 9 should be. But now here's what you need to remember for the test, okay? Your test looks just like this. If there are things you know that aren't marked, you may mark them. Vertical angles. You know vertical angles are congruent. Mark them congruent. The reflexive property, you know they're congruent. Mark them congruent, okay? So mark what you know and then tell me which theorem works. Okay, tell me what you're getting. This first one.
SAS.
No, but I know why you did it. Okay, so here's the deal. This is vertical. But remember, you need this triangle to correspond to this triangle. Does this side correspond to a side on this triangle?
I didn't notice that.
That's a trick question, right? This is not enough info, but hear me right now. Hey, I really didn't try to trick you on the test, but in a situation like this, if you had marked this for me and then told me SAS, I would have given you some credit for that because you knew that vertical angles were congruent. So mark the things you know. That does not mean just start putting marks everywhere because we don't know that, right? If you know something, mark it, okay? If you know vertical angles, mark them congruent. If you know reflexive, mark it congruent. That's very helpful. Like this one. What do we know? SSS, because this is reflexive. So that is SSS. Okay. How about this one?
ASA because of reflexive.
Yes, this is reflexive. So you have an angle that corresponds to an angle, a side that corresponds to a side, and an angle that corresponds to an angle.
Can the second one also be HL?
You can't prove those are right angles.
You can't prove they're right angles. They look like right angles. What?
We did that for this one.
Because to prove they're right angles. Because it's a
If they had given you this, then you could have proved you have right angles. But we didn't have those marked congruent. Okay, what was this one? Oh, goodness.
SSS.
SSS. Now, someone in my last class argued that you could go a different route with this. Do you see why?
No.
So I would do SSS because it's the easiest. But what kind of triangles are those?
Right triangles.
They're isosceles, which means these base angles are congruent. Oh, you know what though? No.
SSS.
Yes.
Oh, it is.
Yes. So you could have marked those congruent, and then you could say SAS or SSS or ASA or AAS, really any of them but HL, okay? But this is your best bet. Don't necessarily go that route. That's just more work. What'd you get for this one?
Any.
Not enough info. Why? Because don't we know this?
Yeah, but that's not an
But what are you gonna call it? AAA?
AAA is not, right? Remember we said you could do a 30, 60, 90 with a 30, 60, 90.
The next one's HL.
Are those congruent triangles?
Nope.
No, there is no AAA. What about this one?
HL.
Not HL. NEI. We know an angle with an angle. We know a side with a side. There's nothing else we know here. So this is not enough info. Okay. All right. This next one I would say gets done wrong quite a bit. SAS. Why not HL?
Because there's no hypotenuse.
Right. We don't, hey, listen. These are hypotenuses, right? They're not marked, so it cannot be HL without a hypotenuse. Hypotenuse is across from the right angle. We don't have it. But we know all right angles are congruent, so side angle side with side angle side will work. What's this one?
HL.
That one is HL, because you have the hypotenuse, you have the leg, and you have right triangles. What's the last one? Angle, angle, side, or if you said side angle, angle, same thing. Why not ASA?
Because it's just not possible.
It's the non-included. This would be the included side. We don't know that side. So you cannot say angle, side, angle, because it's not the included side. No, put it away. Put it away. Away. Questions on that? Okay, we're going to do 3 proofs, and then we're going to just talk through what we typically see in a proof, and we'll be done. This first one, now here's the thing. I would call this a 3-step proof, so I'm going to ditch this last step. I will explain to you how you could make it a 4-step proof if you wanted to, but why would you make a proof longer than you need to, right? So let's just do a 3-step proof for this. So it says, given that AB is congruent to DE. You guys, it is so important that you mark what you know as you know it. Please mark up your triangles, okay? It's super helpful. So mark that. What is the reason for that? It's given, okay? It also says in your given that C is a midpoint of AD and BE, okay? When you see a word like that in your given, what do you know comes? Definition of, right? Whatever that word is, definition of that word. Did you have a question, Nick?
Do you ever have dreams about like geometry?
No, I don't. You don't even want to know. My dreams are so weird. My husband gets so mad at me. I've army crawled across the floor before. Okay, so C is the midpoint. If C is a midpoint, that leads us to AC congruent to CD. Okay, and BC congruent to CE. Notice what I did as I said those. I marked them. Why do you suppose I marked them?
To make sure they're not angles like the lines.
Well, I mean, sure, but just so we can see what we have, right? What do you see right now in that picture? SSS, okay? So we say these are congruent. Why is step 2 congruent? That's definition of a midpoint. And then once you have that, then you can say what they asked you to prove. Triangle ACB congruent to triangle DCE by SSS. Okay? Remember, if you're saying 2 triangles are congruent, it will be SSS, SAS, ASA, AAS, or HL. Those are the only 5 options if you're saying triangles are congruent. Okay? Nick.
So if I didn't do well in the proofs area, but I did like great ace and everything else, but could I get like a B or?
I mean, it depends what not doing well in the proof area is, because there's
Like,
3 proofs on the test, so it's a lot of
Oh,
blanks.
just not good.
Just depends how, I mean, you can be good at parts of them even if you don't get the whole thing, right?
Oh yeah, I guess like reflexive right now.
Yes,
Are you
look
gonna
for
use-
reflexive.
Are you gonna use one column, or is it just mean like?
There's a few on the left that you'll have to fill in, but not a lot.
That's kind of my question, like, are you gonna give us blanks for everything we should fill, or are you just gonna say?
You will know how many steps it is.
Yeah.
Yeah, you'll know exactly how many steps. It's not just gonna be like, hey, fill it in. Nope, I'll give you, like, it's a 4-step proof, it's a 5-step proof, whatever.
So every line should have that.
Yes, yeah. Okay, look at this next one. Notice what this says. Separate and mark up your triangles. That is points on your test. If you do not separate and redraw them, you will not get those points, okay? So look at what we're talking about here. Angle D and angle E. And angle DCF, so that's this angle, and EFD is that angle. So if you look at what triangles overlap using those two angles, you're gonna get triangle DCF. So this is a C, this is a D, this is an F. And then the other one is gonna be this triangle. Okay, this is C, this is F, and this is E. So separate them and then mark what you know. You need to label the points as C, D, F, and E, and you need to mark up what's congruent. So look at what we said here. Angle D is congruent to angle E. And then angle DCF, that's this angle, is congruent to angle EFC. That's that angle. Okay, now they're asking us to prove two segments are congruent. How do I know this information? Step 1, it was given. Okay, so now the next one says, okay, CF is congruent to CF. Why is that? That's reflexive. That's okay. Remember, in overlapping triangles, you will always have reflexive. I promise you, on the problem on your test, that where you have to redraw the triangles, there will be a reflexive property, okay? I promise. It never doesn't show up, double negative, never doesn't. And here's why you mark, right? I marked CF congruent to CF and those angles congruent so that I could see what? AAS, okay? The two triangles are congruent by angle, angle, side. So once I prove the triangles are congruent, everything about them has to be congruent because of CPCTC, okay? Keep in mind this. Hear me right now. Stop writing what you're writing and just hear what I say. If triangles are congruent, it's one of the 3-letter theorems. If your next step after that is segments congruent or angles congruent, it is always CPCTC, okay? You will never do CPCTC and then SSSSASASA. It's always the other way around. The triangle's congruent, therefore everything about them is congruent, okay? Okay. Last proof. This one says, given this information, prove the triangle's congruent. So step 1 is,
Given.
guys, if you get that wrong on this test, I might
Cry?
cry.
Okay.
Step 1, are you trying to make me cry? Okay. Step 1 is always the given. I'm trying to like give you free points. Please take them. Step 1, always the given. Heaven.
You want me to put HL on the right angle?
You have to have right angles to do HL. Yep. Okay, so in this one, I told you these two pieces of information. What does this mean?
Perpendicular.
Perpendicular. Okay? That means perpendicular. So if I say angle RTS and angle RTU are right angles, how do we know they're right angles? Not definition of a right angle.
Perpendicular.
Definition of perpendicular. That's essentially the word perpendicular showing up in our given, right? Definition of perpendicular. Okay? Therefore, if those are perpendicular, giving us right angles, then the triangles are right triangles. Why?
Definition of right angles. The triangles.
Definition of a right triangle is a triangle that has a right angle in it, right? We just said we have right angles, therefore we have right triangles. That's the definition of a right triangle. It is not the definition of a right angle, right? Always right triangle. Okay, so then why do I know that RT is congruent to RT?
Reflexive.
Reflexive. Mark it. Mark that those are congruent, because then you will see those two triangles are congruent by what?
HL.
HL. You have the hypotenuse, you have the leg, and you have right triangles. So those are the three things we need to be able to say HL. Okay, proof rundown. You might want to write these down. You don't have to write these down. We're just going to talk through everything we can think of that we've seen in a proof. What's always step one?
Given.
Given. Please don't get that wrong. What's typically a last step of a proof?
ASA, something like that.
SSS, SAS, ASA, AAS, or HL. Those show up if we're saying a triangle is congruent to a triangle. But what if we go a step past that and say a segment congruent to a segment or an angle congruent to an angle? CPCTC. Okay, so those are the ones that are maybe like the, yep, this is going to go at the beginning, this is going to go at the end. Okay? Some things that go in the middle. What are some common things we've done with proofs? Reflexive. Look for reflexive. It shows up all over. Definition of, let's think through some of them.
Angles.
Midpoint.
Right angles.
Not right angles, right triangles. Definition of a right triangle, definition of perpendicular, definition of a bisector. Can you think of any other ones?
I think
I know there have been other ones, but those are the most common ones that we've done. What else do you see a lot in proofs? Vertical angles. What if I tell you that lines are parallel? What do you think is going to show up? Alternate interior angles, right? If lines are parallel, typically AIA, or one time it was corresponding, but it's usually AIA. Yeah.
You put VAT or put vertical?
You can put VAT, that's fine.
Is that what you usually do? For VAT?
I've never been a big VAT person. I don't know why. I always just write vertical angles, but I don't have any problem with VAT. Anything else you can think of that shows up a lot in proofs? We got that one. That's down here. We did the third angles theorem, which didn't show up a ton, but if we knew these were congruent and we knew these were congruent, then we know the third angles would be congruent.
Will they show up on the test at all, like, for the third angles?
It can.
Well, can you just tell me yes or no?
Nope, I can't. They can show up. I mean, I can. I'm just choosing not to. I want you to be prepared for anything, right? Anything else that you can think of that shows up a lot on a proof? I feel like we've got the majority of them here. Okay.